thank you all for coming. Thank you so much. My name is Susan Knight. I'm with UW Trout Lake Station up the road a little bit. And Science on Tap is an example of the Wisconsin idea, the idea that the borders of the university are the borders of the state. And at Science on Tap, you won't get a lecture, but you have an opportunity to learn about a topic and ask your own questions. I'd like to remind you about our partners at Science on Tap. We have Trout Lake Station, UW-Madison Trout Lake Station, UW-Madison Kemp Natural Resources Station, Minocqua Public Library, the University of Wisconsin Lakeland Badger Chapter of the Wisconsin Alumni Association. I'm sorry, I kind of jiggered that one up. And finally, I'm very sorry, and our host, the Minocqua Brewing Company. So thanks to everybody. And Science on Tap is sponsored and supported with funds from the Brittingham Fund. So thanks to all those folks from the University of Wisconsin. Remind you that there are 4 ways to watch. You can watch right here, as you all are. We have live streaming at the Minocqua Public Library. And Mary's not there tonight, but Peg is there. Peg, our new Minocqua Public Library librarian. And we also have live streaming for anyone with a good enough connection at home. And then we also, which is maybe not too many of you, and then you can watch any event later. We archive all of our events completely, and we also create a short version with a little bit of the introduction, a few of the questions, about 8 to 10 minutes or so, and so those are really great to get a sense for the topic. And those are all on our website. So you just go to our website and go to look for archived episodes or Science on Tap shorts, either way. So I want to make a quick announcement about Kemp. There is a special event coming up this Saturday, Discover the Sedges of Kemp Station, led by Libby Zimmerman. And it's Saturday, June 8th at 2 o'clock. Or the 9th if the weather is not good. And so you can call Kemp and find out more, but they want you to park and meet at the green space by the White House. And they recommend binoculars and a hand lens. Again, that's Discover the Sedges of Kemp Station. So that should be fun. Our next Science on Tap will actually not be until next September. September 4th, our speaker will be Dr. Steve Barksey. And he's going to be talking about sleep and health. So that should be pretty interesting for a lot of us that struggle in that area. But tonight we have Dr. Jason Fletcher from UW-Madison. Dr. Fletcher is a professor at UW-Madison Robert M. La Follette School of Public Affairs. He also has an appointment in sociology, applied economics, and population health sciences. He earned a BS in economics and public administration from the University of Tennessee in Knoxville, and his master's and Ph.D. from the University of Wisconsin-Madison in applied economics. Dr. Fletcher is an economist. He's interested in education and public health. And Dr. Fletcher co-wrote The Genome Factor, What the Social Genomics Revolution Reveals About Ourselves, Our History, and Our Future. And the Genome Factor shows how genomics, the study of all your genes, is transforming the social sciences and how social scientists are integrating both nature and nurture into a unified, comprehensive understanding of human behavior at both individual and society wide levels. And that book is available at our public library. So I recommend everybody go out, or actually recommend that you buy it. So you gotta... Don't go to the library. So here's your trivia question for Dr. Fletcher. Like many scientists, Dr. Fletcher had a rather circuitous path to getting to his current line of work. He had many jobs before becoming an economist. Which of the following did he never have? Assembly line apprentice? Data entry apprentice? Plumber's apprentice? Sorcerer's apprentice. Dr. Fletcher.
Thanks for everyone for coming. I'm really excited to be here. This is the coziest one of these public demonstrations, public discussions I've been to. So thanks for coming, and I really look forward to your questions. So I've been told to set up the problem a little bit, so I have a couple little notes here to do that. So part of the question is about the claim that I make that there's a social genomics revolution, and I want to tell you why I think that's true. And first is I want to say that there's been a genomics revolution that has social implications. So a couple facts about that suggest there's been a social genomics revolution. First is in the last 15 years, there's been almost 90,000 new genetic discoveries in humans, over 4,000 publications over that small period of time, 10 to 15 years. And those findings, 90,000 findings of areas in the genome that matter for health and flourishing in human populations, matter in a lot of ways. And part of how they matter is how genetics is going to be used in public policy realms especially, to make decisions about us. And that's part of where I think we're going to go in the Q&A, so I want to set up the problem a little bit. In the first part of the setup is, let's recall a couple facts on genetics. Fact one, the human genome is approximately 3 billion nucleotide pair in length, so it's a lot of information. Doesn't matter if it's 3 billion, but it's a lot of information. And of that, lots of information, 3 billion nucleotide pairs, 99.5+% of every one of those locations is identical in all humans ever in the past going forward. So 3 billion, 99.5% plus of every location in our genome is identical across all humans. 98% of all our locations are identical to chimpanzees. So there's both a lot of commonality, and it suggests in humans, and it suggests that some of these changes, these differences really matter, or else we'd look and function like chimpanzees. And the other part, so an example of a letter that matters would be the sickle cell trait. There's a single letter in the 3 billion letters that if you have one variant versus the other, you have sickle cell blood cells, and if you don't, you don't. One letter. That really matters. There's another letter that has to do with the ability to digest milk post-weaning, lactose intolerance. So there's just a small number of letters. You can be identical except for one letter and have sickle cell versus not sickle cell. So some of the letters really matter. The other point to recall, so this is nothing groundbreaking here, I'm just reminding you of some facts. The other fact is that these letters are permanent, meaning that you had the same letters essentially when you were an embryo, when you were a fetus, when you were a small child, when you're now, and forevermore. The asterisk there is that there are small amounts of mutations that happen over your life, but in thinking about genetics, you should think that the same letters that you have now that you might get assessed through a company like 23andMe would be the same letters that were in all your cells when you were a fetus, small child, and so on. Okay. So those are some genetic facts. That's not new ground. That's not revolutionary. So that's facts. What's revolutionary is more about technological breakthroughs on measuring at low cost human genomes. So just 15 years ago, the first human genome cost approximately $3 billion to sequence. So if you think about college tuition, is a price that that many of us experience, and how it's gone up so much over the last 15 years, which is true. It's gone up by about 150% over the last 20 years, college tuition. It's one of the highest categories of growth. On the other hand, television sets have dropped dramatically, 90% over the last 20 years of what you get for a television set versus what you would have gotten 20 years ago. Okay, so that sounds like things that you know about. People have paid college tuition and realize it's larger now than it was 10 years ago. So let's go over to the technological improvements in genomics. 10 years ago, 15 years ago, more than $100 million per sequence, now under 1,000. You can typically get a sequence for under $100, so that the scale over a short period of time, 15 years, is a 100 million times reduction in the sequence, in the costs. So there's just no precedent for anything like that over a short period of time. Even in human history, there's probably not a great precedent for something that costs, where the price of something, the cost of something like sequencing a human genome has fallen so drastically, especially in a short period of time. So an implication of that technological change, of how easy and cheap it is to sequence human DNA, is that there are many large companies. 23andMe is one that I'm sure we'll talk about tonight, which has leveraged that technological innovation to create databases of, in 23andMe's case, over 5 million people, humans, in one data source. AncestryDNA.com, AncestryDNA has 14 million people in a single data set who've had their DNA assessed. So that's just impossible when human DNA sequencing cost $1 million per sample. Now that it costs $50 per sample, it's essentially getting free. So that's the technological improvement that has changed, not anything about genetics, but about how easy it is to make new discoveries. So that's actually what's behind how we have 90,000 new discoveries, is that it's so cheap and easy to do the sequencing. And the next step of how those changes in technology have actually been used is to create these large data sets I just described with millions and millions of people in order to make new genetic discoveries, like the 90,000 discoveries, using statistical improvements in data analysis. Those improvements, in some ways, do what you would want them to do. If you have an outcome of interest, like asthma or heart disease, scan the genome of millions of people, looking for locations in human DNA that suggest an increased risk for heart disease. Add those risks up across the whole genome and create a score of some sort that might be able to use, that could be used clinically. So I'm still in the present. This is not the future. It's now